So now we fixed the dangling node problem, but there's a second issue, the idea of a disconnected graph. So we call a connected component a group of nodes which can reach each other, but can't reach anyone outside of their group. And so basically, in this graph right over here, we have two different connected components, right? So if our web graph looked like this, and obviously a lot of the internet might be something like this because the internet's very sparse, as we said, so there's going to be groups of nodes that aren't connected to each other. So we have A, B, and C, which are all connected on one hand, and we have D and E, who are connected on this side over here. So the problem is that if we start in A, go to B, and then go to C, then go to B, and we go to C, B, C, B, and so on. Even if we're choosing within this group over here, we can't ever leave this subgraph. There's no way to get out of this subgraph over here. And the same thing in here is if we're in D and E, there's no way that we can get out of this. We can't get over to this side because there's no link going over there, and there's no link going this way either. This is going to lead to actually an infinitely many solutions. So there's an infinite number of values of importance scores that could satisfy this because we don't have any relationship between these two over here. So when we have no relationship, then basically we can establish any relationship we want and it'll still work. And this is going to be a problem whenever we have more than one connected component because the entire graph isn't one connected component. We have two or three subgraphs. And so we're stuck in one of these subgraphs forever, as we said, by our random surfing philosophy. The solution to this is we add that thing that we neglected initially, where we said maybe the random surfer will eventually get tired, right? So if he's starting at A and he comes over to B and then he goes to C, then back to B again, then maybe eventually he'll get bored and he'll decide to just enter a random URL and then he'll end up on D. And then he can go to D to E and he'll be stuck in that subgraph until he enters a random URL again and comes back to C. So we're basically establishing an artificial link between each node. So we're saying that, in a sense, each node's connected to every other node because there's a way to reach them just through our web browser rather than the actual hyperlink connectivity on the pages. So we add that purely random surfing that we collected initially into the mix.